So we talked a lot about int32 and int64, and these are super important topics. Let me really highlight again that we can sort with these types of numbers, that we can query for them with greater than, and all the things you could do with the normal numbers, these things are possible with number int and number long too, or with int32 and int64, as I should say, because number int and number long are really just the constructors we use in the shell to create these number types. But let's now move towards our high precision double, because that will also be interesting to understand. To understand what it does, let's say we have some database which we use for scientific calculations. So I have my collection science in there, and I insert one new document, and let's say we have two values, A, which is .3, and B, which is .1. And please note, these are the normal numbers as I use them in the shell, and therefore, because the shell is based on JavaScript, these are 64-bit floating point numbers. So they are not these high precision decimals. If I insert this, this will work. If I then find all my elements in there, this looks good, right? The values look the way I stored them. Now keep in mind what I mentioned earlier in this module. Behind the scenes, they will actually be stored with something like this. So there will be more decimal places than you see here, and there will be some imprecision. It's simply approximated to this, and JavaScript, so the shell here, simply outputs it in this approximated value, which of course looks all right here. But we can see the difference if we do a calculation with the help of the aggregate functions of the aggregation framework. Here, I only want to pass one stage, one step in my pipeline, and that is the projection stage. So I will find all elements and project them into something new. And there I will add a new field. And let's name this result, whatever you want. And the value for this field has to be a document, as you learned in the aggregation framework module. And here I will subtract. I will subtract two values which are passed to this array. And I will subtract A and B. And they have to be referenced with $signs here so that MongoDB will look for these fields. If I hit enter here, you see something strange. The result of A minus B is not 0.2 as you would have expected, but this value. And this shows you the imprecision I'm talking about. These values are not stored exactly. And in some use cases, in a lot of use cases, this might not matter. Even if you're building an online shop with products where you store the price, where you would say, of course, I don't want to lose some fraction of a cent. Even in such a case, you could be fine with these values here, because you might only use that price to display it on your web page, where the approximation will be all right, because you don't have that many digits you approximate. You only show two decimal places, and these will be correct. And even for you, then kind of charging this, you might be fine, because you sent this to some third-party service. You send your value as it is returned by the database, so something like this. You send that to the provider, and you then rely on the provider charging exactly that and not some incrementally lower amount. So you might be fine using these values. But if you do calculations with them, if you work with them on the server here, because aggregate, of course, executes this on the MongoDB server. So if you do something like this, where you extract data, return value from the database, and you end up with a result like this, you might, of course, have a problem, because that is probably not acceptable for your application then. And this is exactly where this high precision double, the 128-bit double, can help you. So let's have a look at that in the next lecture.